We're going to do a full overview of all different kinds of things that you can achieve with Stratosphere UX, but most importantly, we're going to talk about automation. So we're going to talk about automating things that can be either delivered to your inbox or utilizing Stratosphere to say, tell me about things before they break and what those things happen to be. We're going to talk about predictive analytics. We're going to talk about the side effects of Optimizer, and we're going to talk about the emergence of artificial intelligence inside of Stratosphere and how it's changed everything for us. So first and foremost, we're going to talk about a report. I know this seems so bland, but this report, I would argue, is one of the most effective parts of Stratosphere when it comes to illustrating and isolating what are the good and bad parts about an environment. So we collect over 6,000 metrics per machine, per user, per hour. When you compare that against other solutions and other systems, it dwarfs pretty much anything that you're going to find inside of the industry. And that means that we have a lot of leeway to tell you things that you may not know about. So what we did is I ran a diagnostic findings report inside of my own environment, and we're going to take a look at what is inside this report, how to read it, what kind of information we can glean from it, and why you should be automating this report so it's delivered in your inbox on a weekly basis. So this report's divided into 4 sections. We have scope, findings, user experience, and recommendations. So the recommendations we're actually going to talk about based on the findings inside of the report. And then we're also going to take a second step and see what artificial intelligence can give us in terms of recommendations. First, let's talk about the scope. This was a report that I ran a couple of months ago inside of the environment. I found a bunch of weird things, which is why I kept it, because it's always fun to talk about. We have 74 users, 123 machines, 120 machines, 43 vCenter hosts, 1 vCenter import. Now, it's really important to remember that when it comes to this report, it is agnostic, meaning I can run this against physical, virtual, cloud, desktop, laptop, workstation, running Windows, Linux, Mac, or even thin clients. And this report will be just as pertinent if I had run it inside of a box stock Windows 10, Windows 11 VDI environment. So try to keep that in mind. This is very much a report that is universal. Next up, we have a little bit of a precursor of things to come. This is the UX profile definition. Now, remember, Stratosphere is a learning appliance, meaning the second you turn it on, it's immediately going to learn about your environment and your users. And what we'd really like to be able to do is take that learning process and feed it into a predictive analytics algorithm. So, obviously spoiler here, but we're going to talk about that a little bit later. And this entire learning process defines the UX profile definition. This is my fingerprint. Every customer, every organization is different, and Stratosphere is going to learn your fingerprint. That way, whenever there's a deviation, whenever something is going against the grain or something bad is going to happen, Stratosphere will tell you before it reaches critical mass. That's what predictive analytics should be bringing to the table. So this is what Stratosphere has learned about my environment. And whenever you see color inside this report, in terms of green or yellow or red, it all calls back to these values that are learned from Stratosphere. So these aren't, best practice values that we just dump into the product by default. These are things that are learned for your specific environment. We also have user groups. I can import these from Active Directory, vCenter, CSV, pretty much anything I want. I have machine groups, and you can see I've done a bunch of these imports from a few different other places as well. And finally, we're going to get into the core of the data. The first thing we're going to look at looks a little bit messy, doesn't it? This is the machines. What machines are logged in, what users are logged into them, and then plotted over that is CPU memory for both the machines as well as any virtual hosts I have. Now, a couple things to remember. The important thing to glean from this data is concurrency. So the light blue lines, those little lines over here, they represent who's logged into their machines. The dark blue lines tell me what machines are on versus the users logged into them. And already I'm learning something. I'm learning I'm only about 50% concurrency. So if I want to save money in terms of energy costs or things like that, I can afford to turn almost 50% of these systems off. I'm also seeing that memory, for the most part, is in a good space because I'm seeing my host memory and my hypervisors. If I look at my machine memory, it's pretty much in the same place, it's 60%. And the host CPU and machine CPU seem to be okay, but we're going to dive into that in a little bit. So first piece of information, nice to know, but nothing earth-shattering. Now, the next thing we're going to look at is pretty important. This is measuring something called CPU queue. disk queue, and disk IOPS. Now, in just about every environment, I would say this is important slide number 3 in the top 10 list. This is teaching me what my bottlenecks are. And what I'm looking for here is I'm looking for anomalies. I'm looking for something weird that kind of stands out. So I'm going along and I'm seeing this. Oh, March 31st looks pretty good. We got some CPU queues that are around 6 and 7, and everything looks good. Well, there's a little spike on the first, and then oh my goodness, what happens on April 3rd? April 3rd, I see this massive CPU queue spike, followed by a disk queue spike. And as human beings, we are designed to see things like this. When one of these things is not like the other, it stands out to us. And that's exactly what this report is teaching us. I have an anomaly. I have a problem with CPU consumption during this point. And it's at that point, if I have more questions, first I would go through this report. Second, I would go through some of the more advanced parts of Stratosphere and dig inside of those machines and saying, what were you doing on April 3rd at 4 p.m. that caused these things to spike so high? And remember, CPU queue, I would argue, is the best metric for measuring how busy a machine CPU is, because Windows isn't very bright all the time. If you ask it, if you open up Task Manager and say, hey, what's my percentage of consumption? And it says 2%, 3%, 20%, that's great, but it's only based on the processes it's aware of. When you start taking a look at the things going on in the background with device drivers and hardware and things like that, especially when we start talking about things like 2D video, those things consume the CPU to a huge degree, and Windows doesn't really catalog that very well. So a lot of times when you start measuring things like CPU queue, you see a really big disconnect where Windows says, hey, I'm at 50% CPU capacity, and the CPU queue says I'm at 26. And to give you a frame of reference, what your queue is supposed to be is, how many cores do you have? If you have a 4-core machine, your queue is supposed to be 4. If you have an 8-core machine, it's supposed to be 8. Now, I don't have any 16-core machines in my environment, so this giant spike at 4 p.m. up to 15 says my CPUs were crazy busy. Same thing with disk queue. Disk queue is exponentially more important when we're talking about I/O. So in other words, when we're talking about IOPS, it's a little bit different than CPU queue or memory or anything else, because those things, CPU queue, the memory, these things are measured in fractions of billions of a second. When we start talking about I/O, when we start talking about disk, these things are measured in instructions per second. So any pain that you feel in the disk is felt tenfold by the users because it is the slowest subsystem of your computing system. So we like to try to keep the disk queue at 0.3 or lower. So this giant spike to 5, that's a bad thing. And this is why this report is so important, is because if you have strange intermittent issues that you can't explain, this is always your first step towards getting your answers. So moving on, we're also going to understand things like the I/O rate. And this teaches us what was going on with the network during those times. Oddly enough, at the exact same time we had that CPU queue and disk queue spike, there was a network spike as well. So we're starting to see correlation. We're also going to see things like your host disk IOPS versus your I/O rate. So is the storage of your hypervisors set up properly? We're going to see things like login delay versus application load time versus host disk latency. And this is important because it's teaching us, are your application load times or your login delays impacted by what the disk is doing in the background? Sometimes the answer is yes, sometimes the answer is no. But either way, we need to understand causality. Now, we're going to get to what I would say is probably the most important slide, number 2. And this one seems benign. It doesn't seem really important, but what it's teaching us is a big deal about stability. So it's laying out 3 things. It's saying I have page faults, which page faults are great, but they're not the star of the show here. And then I have GDI objects, the yellow line. That is a measurement of 2D video. One of the most often underlooked aspects of cloud VDI and laptops that we see in the modern age, because people have 4K monitors, they might have 2 or 3 or 4 of them, and they don't consider the fact that 2D video is not rendered by your GPU. 2D video is rendered by your CPU. It is no longer accelerated. So the more that you're doing with those huge high-res 4K monitors, the more you're consuming CPU without really using it. And GDI objects is a way of measuring 2D video objects. So a lot of times what we find is with so much 2D processing, it can affect stability. In my environment, seeing the opposite. This means that even though I don't have a crazy amount of GDI, I have application instability, these giant orange lines that keep going up, which means I have other problems inside of my environment that aren't necessarily related to my GDI. So what does that mean? That means I have instability. And the reason I have instability is usually due to bottlenecks. And we're going to talk about that next, because this, and I know this is really bland, it's hard looking at the numbers when we've seen all these pretty graphs for the rest of the session, but these numbers are very important because they teach us your average metrics of the environment, which are nice to know. The peak average, which is a collection of hourly maximums for everybody, which I would argue is the most important metric you can look at, and peaks, which is the maximum that everybody saw. Now, based on what we've just seen about the environment, what do we know? We know we have a CPU problem, but we don't really know how bad it is. So let's go and take a look at the CPU queue. It says most of the time we're at 4.0, which is good because most of my users have quad cores. We can see the usage is at 8% according to Windows at that time. And then peak average jumps up to 96, and oh my goodness, the CPU queue goes up to 160. That is the first giant red flag, because whenever we see CPU go over triple digits, you will have application crashes. And you notice during that time, the number of ANRs that I see starts steadily going up. So the least I have is 2, the average is 3, and this is on a per user basis, so this is a pretty big deal. We see the ANRs going up to 4.0 peak average with a peak of 19. So I really have some big stability problems in this environment. And performance is good, but what management really cares about is, can people do their jobs? And if I start seeing 19 applications crashing over the course of the week for the majority of my users, that's a big deal. We need to figure out how we can drop those numbers. And when we're looking at this, we can already see why my stability is so bad. My stability is bad because my peak CPU queue is 1149. Remember, I said things are going to start to crash once you get past triple digits. So if I'm past 1,000, apps are going to crash, and they are going to crash hard. And most people don't have any visibility into this whatsoever. And this is why the data that Stratosphere provides you is so important. Just moving along with some of these other metrics here, we can see that my memory consumption, most of the time I'm pretty good at 50%, but sometimes I get really high at 100%. You want to keep an eye on that, because if you get to a point where memory and page file are both at 100%, guess what? The machine crashes. We want to stop that from happening. Next up, we can see that IOPS is pretty good. I'm a little bit above average. Most companies are around 20 when it comes to IOP consumption. I'm at 36. I'm pretty heavy. We can see our peak average at 6,496. All of a sudden, the disk queue jumps up to 26. Now remember, I said, I don't like that. I want to keep it at 0.3 or lower. So if I'm at 26, that's kind of screaming at me, hey, your disk is too slow. You need to do something about that. Or you need to decrease consumption on the machines. We'll talk about how we can do that. Finally, my peak IOPS, 220,000, is really high, and we see that the queue is completely maxed out. The highest it can go is 100, so that's a bit much. So again, we need to do a few different things here. We need to look at this holistically. We need to say, A, is there stuff I can get rid of so I can decrease this crazy CPU and disk consumption? B, is there any way I can increase how many virtual resources or physical resource a machine has? And C, what can I do to optimize it to make these numbers better? So we're kind of burning the candle at both ends. And then from a virtual or VDI perspective, I can also see what's going on with the hosts. So my first big problem is I don't have a lot of free CPU. So I can't just throw CPU at these clients to make things better. I'm at 99% peak, which means there's not really a whole lot left for me to give out of these servers that I have. Memory, same thing. So instead of just saying, hey, I can throw resources at these machines to make the problem go away, give them more RAM to decrease paging and decrease IOPS, give them more CPU to decrease the CPU and make the applications more stable, I'm between a rock and a hard place. I can't do those things. So the only options I have are optimize the apps and optimize the systems. So we're going to talk about how we can do that. Before we do that, though, we need to learn a different perspective. We need to understand things hourly. Why? Well, because I want to see boot storms, login storms, IOP storms, antivirus storms. And when I look at a week's worth of data and then break it down hourly, suddenly the perspective changes. So when I look at the machines, wow, this is a whole lot easier to digest. When I look at the CPU queue and the disk queues, well, wait a second. Looks like my peak pain points are at 4 o'clock. And I can see some other pain points that are starting to develop here. So when people first log in at 9 a.m., there's a spike. When people just go to lunch and they're browsing around the web and they're messing around on Chrome, there's a spike. And when they just go home for the day, there's another spike. Is this normal? Yes, this is what we see in a lot of organizations. But what's not normal is the amount of spiking that I'm getting, that weird anomaly we saw before. We have to solve that problem. I'm also going to take a look at the I/O, and in terms of hourly, host disk IOPS and I/O rate, the login delay, the application load time, the latency, and all these things are teaching me things. But once again, one of the most important actors here is not obvious, which is the ANR and the GDI, which is teaching me when my instability is occurring. So the huge amount of instability that I'm having seems to be around 1700 to 20 hours, and then I'm seeing it between 4 a.m. to around 10 a.m. It's never perfect. In fact, I can see that the ANR drops to around 20 at around 1 o'clock in the afternoon. So this is screaming at me, you have an unstable environment. You need to go and fix that in any way that you can. We will give the tools so you have the most information to go and do that. It's also going to teach me things like when I'm seeing these key metrics average per hour. So every time I see one of these red columns, this is something to pay attention to, because I can see that there are times when my memory and page file are maxed out. There are times when CPU queue is huge, and these are based on your numbers, your idea of normal. So when I see stuff like this, it means I should be paying attention to it. We're also going to understand individual consumers. So I'm going to see what's going on with individual CPU consumers from machine, applications, a users, and a host perspective. I'm going to do the same thing with memory. I'm going to do the same thing with I/O, so I can figure out where is this crazy amount of IOPS and CPU coming from. But then I'm also going to take apart your applications. I'm going to say, all right, who's using what applications and under what conditions are we seeing these resource problems? So if I wanted to find out where is all my CPU going, co-design is actually one of my high consumers here, followed by MRT, POQ exec, and some other fun stuff. If I want to understand where my memory is going, I can see it's actually Tomcat and Edge that are consuming the most of it. So if I want to reduce that memory consumption and CPU consumption, that's a couple of places that I can go and start tagging things out. IOPS. Well, if we wanted to know where our IOPS was going, here you go. Somebody's running VMware Workstation on a VDI machine. That's always fun. We have code design running an SDX helper, and these things are chewing up almost 10,000 IOPS a piece. So I might want to go to the people that are running these things. Stratosphere can tell me and say, hey, what are you doing with code design? Or why are you running VMware Workstation on a VDI system? There's a more efficient way for you to go and do this. So when we start pulling out things that aren't necessarily mission or system critical, we can say, all right, we can drastically reduce consumption from that angle. GDI objects. Now, this one is something that's really overlooked, that's really important. Remember, this is a measurement of 2D video. I'm going to give you a frame of reference because none of these numbers really kind of relate to anything, right? A frame of reference is a movie. So if you watch a 720p Blu-ray video and you play it back with a nice efficient player like GOM or VLC, I don't care where you downloaded it from. We're not the MPAA. Anyway, if you have any of those things and you play it back, you're going to get about 1,000 GDI objects. So wait a second, Task Manager is chewing up 1849? So you're telling me that simply opening Task Manager will chew up 1.8 times what it takes to render a movie? Yeah. Well, look at Zoom. Zoom's at 919, about the same thing of what it takes to render a 720p Blu-ray movie. Is that all being pushed onto the CPU? Yes, yes, it is. So having access to this data is absolutely massive. We can also teach you about the application usage time. We can teach you about your user experience for your users, your machines, your users with the worst experience. If you want to know where your low-hanging fruit is, here it is. The machines with the worst experience, the summary of machines, locations by cities, or where they're physically located. We have customers and clients everywhere, so it's easy for us to see stuff in weird places. We can see things in different states, different countries, and then, of course, we can also give you workday comparisons of the different types of users we have in the environment. So your high, your mid, and your low end users, so you can identify them. And I can even teach you the difference between your physical and your virtual machines. So recommendations. What would I recommend if this were my environment? Spoiler, it is. And I were seeing things like this. How would I make the environment better? Well, there's a few things I could do. Number one, that user who's running VMware Workstation on a VDI machine, we're going to get rid of that because we don't need the CPU, the memory, and the IOPS consumption that it has in there. And we're going to look at that weird code application and see if we can consume less with it. But the other thing that I want to do is talk to my management about expanding my infrastructure because I am clearly maxed out. And I also need another ace in the hole. I need a way of optimizing the system with a minimal amount of work. And we're going to talk about how we do that in a little bit. But before we do that, let's talk about the elephant in the room. Okay. Me reading that report, first of all, that was really boring, regardless of how excited I get about it. And second of all, in order to understand that level of data, you have to have years and years and years of experience. Isn't there an easier way? And that's something we've been asking ourselves a while, is because there's only so many map voyages to go around. So what we need is an easy way to be able to take the huge amount of Stratosphere data and distill it down towards something that anybody can do, anybody can read, and you don't have to be an expert to do it. So we're going to go jump over to the second part of our demo, which is this. I'm going to actually utilize an AI structure. I'm going to use ChatGPT. Now, remember, I can use anything I want here. If you want to use Copilot, you want to use your own integral AI, you want to use something that your company has, private, whatever, we don't care. What we found is the majority of the modern AI structures lend themselves extremely well to Stratosphere data. So what I'm going to do is I'm going to open up ChatGPT. And I'm just going to simply type in a single question. The question is, can you analyze this report for me and tell me what the user experience issues are? So I'm glad we're recording this because this one phrase is worth its weight in gold because it's going to do all the heavy lifting for us. So I'm going to say, hey, ChatGPT, can you do that? And it's going to say, yeah, sure. Give me a report. So what I'm going to do is I'm going to go and take the report that we just had, and let's see if I can go and find it, because of course I didn't display this thing properly. Oh, there we go. So diagnostic findings. Now I'm going to drag and drop this report directly into ChatGPT, and I'm going to wait for this little circle to go and populate itself. And as soon as I do that, I hit this little arrow button and watch what happens. Oh my goodness, the ChatGPT has just done my job for me. I have literally just AI'd myself out of a job. So it's covering every single one of the things that I was complaining about. And not only that, look what it's doing. It's saying, all right, I have some high login delays and above 70 seconds, and my applications are a little bit low. And it throws in these little exclamation points to say, hey, this is a big deal. You should probably pay attention to it because applications aren't supposed to load in 3 minutes. They're supposed to load in 3 seconds. And that CPU queue that I was going on and on about a broken record, again, there's a double exclamation point in that to say, hey, this is a big deal. So this AI structure can take everything that I do and boil it down to 30 seconds. So you might be asking yourself, well, Matt, why didn't you just start here instead of taking us through that boring report for 15 minutes? And the answer is, I want you guys to understand how important the data that Stratosphere offers is, because you can look at any other company that does UX and DEX data in the world. They don't have this. No one does. So yes, it's a little difficult to understand, but the good news is that AI simplifies everything for us. And not only does it cover every single thing I was just talking about, it also covers some things that I didn't cover at all, like my location-based gaps, my environmental gaps, recommendations. It's basically telling me everything I want to know within 30 seconds of taking my Stratosphere data and running it. So if you do this, if you install Stratosphere in your environment, if you push out Stratosphere agents, which by the way are barely consuming any resources, they consume less than 0.1% of CPU, run it for a week, and then just take that data, run diagnostic findings, and push it into AI, it will do the work for you. Now, this is not just a commercial for AI, because obviously there's a reason we're talking about bringing this data into Stratosphere. And the reason is that this is ultimately going to be the future of Stratosphere. We recognize that having this much data is great, but analyzing it's difficult. So if I can simply take this data and dump it into ChatGPT and give you something that's completely world changing, then why can't I just have a button inside of Stratosphere that does it for me? Or maybe why can't I have my own AI appliance that talks to Stratosphere and gives me this data? Well, the good news is both of those things are currently in alpha, and you should expect something from our company within the next 12 months in regards to AI. And now we're going to talk about more automation inside of Stratosphere. So those reports that I talked about before, the diagnostic findings, utilizing that with AI, it's important to note that every single report inside of Stratosphere can be automated, meaning that I don't have to log into this interface in order to get the benefits of Stratosphere. So if you have a problem with, for example, CPU, there are dozens of CPU reports that I can automate and have delivered in your inbox daily. And the only thing I have to do that is click this little button here that says edit and tell it, yes, scheduled, and I want to run this daily, hourly, weekly, monthly, for whatever time that I want. And I want to email it to matt.boyajian@liquidware.com, and no reply is no reply. And now every single week, every single day, whenever it's important to me, I have Stratosphere data in my inbox. I love doing this with diagnostic findings, and I will send it to my engineers and architects on a weekly basis so they can compare things. But not all of us have time to read reports. And to quote the great Homer Simpson, can't someone else do it? I would very much like somebody else to monitor the environment for me, do the heavy lifting. And if something's going to break, say, oh, by the way, this is going to break, run a report or log into Stratosphere, and I'll teach you what you can do about it. So the good news is all of that is baked into Stratosphere by default, and we call the entire over-encompassing feature predictive analytics. So what is it? How do you turn it on? And what does it do for you? So let's go take a look. The first thing we're going to do is we're going to jump into the administration section. So this is the inner workings of Stratosphere and configuring it to do all the things that we want. And if you've ever worked with me before, you've seen this area because this is where I usually start with health checks. I'm making sure that Stratosphere is working correctly. The first thing I need to make sure that predictive analytics functions correctly is I need SMTP. I need a place that I can use as a relay to forward this information outside of Stratosphere. The good news is newer versions of Stratosphere support every variant of SMTP you could think of. If you have Office 365 and you're using external, if you have user IDs and passwords, if you have any of this stuff, it's automatically going to work with it, which means we have access to SMTP even in the most locked down environments. If you do whitelisting, blacklisting, all that's fine. So that's step number one, enabling SMTP. The second thing I need to do is I need to run Stratosphere for at least 1 week with as much data as you can possibly give me. I'd like to see at least 80% of the users that are having any kind of connectivity or performance issues. Once I have that data, Stratosphere is now going to say, oh, I can see all that, and it's present inside of the overview. So I have this data going back, in this case, months. So I now know the two precursors I need to get predictive analytics are working. I have data, and I have a place to push the data. So the next thing we're going to do is I'm going to jump into this little area here called profiles. Now, profiles serve a couple of different purposes for us. If you're using Stratosphere to assess machines and build new environments, what we call assessments, you're going to be in something called the fit profile. If you want Stratosphere to be used as a predictive analytics tool, you're going to be here in the area that's called UX profile. Now, the process here is really ridiculously simple, but the math behind it is not. So what we're doing is we're using a series of probability statistic mathematical equations called standard deviation. And we're doing this across every user for every minute of the day during the baseline period. So in this case, I'm looking at the environment areas for a week, 7 days. I'm saying, all right, I have a week's worth of data. I want you to examine every single one of these metrics during that time for every user. And ideally, I like to have the checkboxes set up this way. I like to have it so it's set to only include data when users are logged onto machines, because users that are not logged into machines or machines that are idle, that's not part of my user experience values. And I uncheck auto adjust and reset calculations and baselines and thresholds daily. If you have any questions about that, please ask me offline. There's only a couple of very rare solutions that I use it. Most of the time, all I do is this and this, 7 days users logged in. And then what I do is I click this little button up top, calculate profile settings. It's a very fast calculation. But what it's doing is it's going to do a standard deviation calculation for every variable, for every user, for every minute of the day. So my login delay, my application load time, my queue length, my memory usage, all of these are part of the calculation. Now remember, these variables transcend both environments as well as operating systems. So it doesn't matter if I'm a Linux user or a Mac user or a Windows user or a desktop or a workstation or a laptop or a server or cloud or VDI or local, none of that matters. All of these metrics span those things. So the good news is it's very set it and forget it. You don't have to think about it. So after I click this button, we're then going to be given a profile. And you can see all of these things have been filled in for me, and some of them are fairly arbitrary, and the weights have been designed and all those things. Why is that? Well, again, this is my environment. This is my idea of normal. Now, there's a couple of variables that I generally don't like going beyond. So you heard me gripe before about disk queue length. I do like to have that as a fair value of 3 and a poor value of 1, just because disk is very important and I want to be told about it. Now, just be careful if you start putting values like this in here, Stratosphere may get more aggressive on you and start inundating your inbox saying, hey, your storage is terrible, your storage is terrible. So keep that in the back of your head, is that if the environment is really poor, and I'm starting to tell you, use these best practice numbers, you may get a lot of basically reading some Stratosphere saying, hey, you got to upgrade your storage now. But beyond that, everything else is going to be pretty basic in here. I do like to keep the queue lengths at the number of cores for fair and double the number of cores for poor, which is what the learn value is in here. Every other value that Stratosphere learns, you can leave alone. It's all completely subjective. Now that we've got all this ridiculously heavy math out of the way, what do we do with it? Well, we use it as a canary in a coal mine. We use it as an early warning system. And the way that we do that is, now that we've got all the heavy data of a week's worth of data, we've analyzed it, we know what's normal for you, we've inherited a couple of best practices. Now Stratosphere is locked and loaded to tell you what's going to go wrong in an environment before it does. And the way it does it is very, very simple. It does it in the alerting section. Now, the alerting section has a lot of different functions to it. So there's a lot of things that we can do. We can alert based on, for example, unauthorized activity, network events, host events, disk IOPS, machine events. The one that I care about is this one right here. So if I want to turn on predictive analytics, I need to turn on alert based on poor VDI UX rating. And the number that goes in this box is 1% of the user base. So if I have, really easy, 100 machines, boop, I put in 1 machine rated poor for VDI UX since the last check. If I have 1,000 machines, I put in 10. If I have 10,000 machines, I put in 100, and so on and so on and so on. Now, wait a second. This says rated poor for VDI UX, and the profile keeps mentioning VDI UX. Is this a purely VDI play? Absolutely not. This works equally well on VDI as it does on physical and cloud. So the fact that it was geared for VDI during its inception has no bearing on how we use it now whatsoever. In fact, it doesn't matter what you use in it, it's going to be equally effective as providing you detail on what's going to go wrong before it does. Why? Well, let's think about this for a minute. I've learned what normal is for me and my users over a long-term period of time. And I'm saying if we see a 1% deviation, a super small deviation in user experience, alert me. So what is Stratosphere going to do when that happens? Well, what it's going to do is it's going to alert based on either an SNMP version 2 trap or an email notification. You know, my favorite is going to be email notifications. And when this occurs, it's going to say, I have a user experience alert based on X, and it's going to say CPU queue has increased by something, or disk queue is increased by Y, but basically it's going to give you a detailed blueprint on what's going to happen in the environment before people are calling the help desk. So this is huge. It means I don't have to be an expert in Stratosphere to get the best out of it. All I have to do is turn it on, learn it for a week, click a couple of boxes, and now I've got grade A predictive analytics with thousands of metrics at my disposal to make everything work the way it was supposed to. All right, so that is what we have for predictive analytics. And now we're going to come into demo number 4, which is a callback to the first demo we gave for diagnostic findings. So at the beginning of diagnostic findings, when I was going over that ridiculously huge 49-page report, I said what? I said, I've got a couple of ways I can fix these problems. I can Fix my CPU and disk problems by what? Well, I can get rid of some of the applications that were in there. Someone was running VMware Workstation at a VDI system, which is crazy. It's inception of VDI, if you think about it. And I also said that I need to request more hardware. And all those things are great. I can also do some things like dig into my images and maybe do some image optimization. But again, a lot of that is simply not enough. So what's great is we have a function in Stratosphere that can drastically help you with these things and do so automatically. And it's called Stratosphere Optimizer. Now, where you find Stratosphere Optimizer is going to be all the way over here in Hub Administration. And if you go into connector ID keys, these are the settings that we actually pull from Stratosphere in relation to all the things that we grab. And there's a lot of really cool stuff in here. And then way down here at the bottom is this tiny little guy. It's seemingly, so tiny, so insignificant, but it's a big deal. This is process optimization. So what Process Optimizer does is a couple different things. So if we take a look at Windows in particular, Windows is kind of a funny little bird. What it does is it says everybody gets equal footing in terms of processes. So if I open up Task Manager and if I go to my processes and go to details and I took a look at all the junk that's running on this system, and if I just right click on any one of these, like the game input service, which is here for God knows what reason, and I look at the priority, it's normal. Everybody's priority is normal, whether we're talking about Edge or WebView 2 or Fathom, which is my AI note taker, or Chrome, or any of the other stuff I'm running, everything is given equal footing. And that's a problem because if I am CPU constrained, if I am disk constrained, if I'm constrained in any way, I have, in some cases, thousands of processes fighting over that CPU and that disk. So what Process Optimizer does is it says whatever's in the foreground, whatever's in focus is going to be given above normal priority. So in my case, it's Google Chrome, or it might be PowerPoint, or it might be any of the other junk that I run in the system. But whatever's in focus is given above normal priority. Whatever's not in focus is given below normal priority. Now, we've been running Optimizer in enterprise environments for quite a few years. And originally, the way we kind of incepted this was, oh, it's just going to make systems faster. So especially if I have older, slower systems with not too much CPU, because I'm giving higher priority to what is in the foreground and lower priority to the thousands of threads in the background, it's going to drop the CPU queue a little bit and systems run quicker. So the user says, yay, this is faster. So I can squeeze more life out of my laptops by a few more months, maybe even a year. I can move to a lower tier of VDI consumption. So instead of everybody getting 6 cores, maybe they get 4. Or maybe if I have user experience issues, it'll iron some of those out for me by dropping those peak CPU queues. And over a few years, it actually surprised us because what we found was not only did CPU queue get lowered from a peak average and a peak perspective, but the thing that really surprised us was, you remember when I was talking before inside of the diagnostic findings report, and I said whenever we had a CPU spike, a really big spike, apps would crash? Well, Optimizer was reducing those huge CPU spikes by spreading the load out over time. So the really funny side effect of this was Optimizer makes applications more stable. Or a better way of saying it is Stratosphere Optimizer makes your environment more stable. Because if we're being honest, our management, if we say as engineers, as architects, as admins, hey, I made everyone's logins 10 seconds faster, you get a pat on the shoulder and good job. And aside from that, they really don't care. You saved us a little bit of time and money, but you know what? That's OpEx. We don't care. What they really care about is CapEx and productivity. So if you were able to go to your management and say, I could make our applications in our CPU constrained environment 30 to 70% more stable, that's huge. That is absolutely massive. And that's exactly what Optimizer does, is by taking those huge peaks out of the CPU, giving the applications in the foreground more resources and reducing consumption on all those background processes, ANRs go down substantially. We've seen huge numbers here. And the only thing you have to do this is turn on Process Optimizer. That's it, this little checkbox right here. You also have the ability to choose what kind of profile you want: single user, multi-user, conservative, aggressive. You can exclude some paths. I usually suggest that you just leave these things alone. And then we can also disable or enable memory trimming. The golden rule here is that if you have more IOPS than memory, you enable memory trimming. If you have more memory than IOPS, you disable memory trimming. My environment, IOPS was a problem, so I'm going to disable it. And now I can say, all right, optimizer is enabled. How do I measure it? Well, you measure it with Stratosphere, because Stratosphere has reports that can say, hey, show me the environment before and after with Process Optimizer and show me why it's better. There are dashboards in Stratosphere that we can use to show you it's better. But most importantly, over time, I can show you that applications not responding is decreasing simply as a result of having us there. And that, ladies and gentlemen, is the big demo I wanted to showcase today. Thank you so much. See you, Sun community, if you have any questions, and have a great day.